which had a nice example of interfaces. And I'll tell you about the solution. And then we'll do kind of an interface review, because I'm sure I confused lots of you in the last class. And then we'll jump into a lecture lab, which gives you a little bit of time to practice data abstraction with the integer set abstraction that we created in class. So just to go over some things here. September 23rd through 27th. So we have polls set up on Piazza for each of the assignments that you'll do. It's really like one poll a week. Really like you to go and vote on those polls to kind of let us know whether you enjoyed the assignment, what did you learn from them, were they too easy, too hard. You know, they'll kind of give us feedback and allow us to improve the assignments. Not just for this class, but also for the next term and the one after that. Also, assignment 3 is out. Assignment 3, unlike 1 and 2, is a little bit more difficult, more challenging. So for assignment 3, it'll be kind of difficult to get 20 points, all 20 points. So if you get like above 15, it's great. You know, consider yourself like really having understood the concept. You know, so we don't expect all of you to get 20, and you don't really need to, right? Lab 3, that's ongoing. Exercises are posted on the website, and then readings for Friday and Monday. On Friday, we're going to start a new topic. So just be prepared to read new material and jump into a completely new topic on Friday. So I also wanted to remind you, so these things are being recorded. Brian is in the back manning the camera. So the lecture for Monday's lecture is already posted on YouTube. So hopefully these will be recorded every day and everything will just work. The ones last week didn't work out, but hopefully we'll continue posting them. Okay, so let's jump right into what we're going to be doing today. So today we're going to be doing assignment 2. Just kind of a review of what assignment 2 actually is. So in case some of you have already started assignment 3, here's kind of a review. So assignment 2, you're given this method within the Where Am I class. And your task was to complete the body of the method, right? No editing anywhere else. And the idea is that you're supposed to use this locator service, which is given by the iLocator site. And you're supposed to query it, ask for how long does it take for you to reach different continents, and then return the appropriate continent name string. So I think most of you got like 20 points on this, so it wasn't super difficult, but there was a variety of solutions. Right, and kind of the object-oriented way of doing this properly is to rely on state. Right, so there were a lot of in a lot of the solutions that you submitted, there was kind of deep nesting of if statements, where you would check, you know, if you know time to Africa is less than time to Europe, and time to Africa is less than time to North America, and so on and so forth. You would build these long if statements. And then you would put, you know, output, you know, I'm an African. So that's definitely the right solution to this, but it's not the most elegant one within the context of Java. So here's what our solution looks like. So in this solution, you'll notice there are if statements, but they're not really nested that long, you know, that deeply. And what we're relying on is state. Really, when I mean state, is that we're defining some variables, you know, or fields, and we're having those variables track some information for us. So here I'm defining the variable integer old, told, and I'm initializing it with, you know, time to Africa. And I have another string called continent, and I'm initializing it to have the string Africa. And what I'll do next is I'll use the locator service and query it for times to different continents. Antarctica, Asia, so forth. And every time I call it, I will potentially update my state. Right, so I'll update told, time old, to be tnew, if my told is greater than whatever the new value of tnew is. And also set the right continent name. So by the time I run through the series of if statements, my continent string contains the right continent. Right? So I basically just update it whenever I see a better version, a lower value, and then I just return whatever is in that variable. So this is a very stateful approach to solving this problem, right? I have a few more variables, and I have to keep track of them, and I have to update them. But as a result, my code is much neater. It's more elegant, right? So my if statements, they're kind of very similar and they're very short. Okay, so not very complex branching logic. Any questions about this solution in particular? Great. Yeah, so for a lot of the assignments, the solutions are not going to be, too long or too complex. We're just trying to get you to understand the concepts that we're getting to use here in the lecture. All right. So interfaces. So Gail was kind enough to put together an example, a second example of interfaces. So last time we learned interfaces through the integer set abstraction. And we created two kinds of integer set, the linked list integer set and the hash set integer set. And the idea was they were both implementing integer set and they had different performance characteristics. Right? That's kind of what we did last time. So this time, Gail created this example called an engine interface example. And in this example, there's really like 4 files. And I'll just demo it for you right now. So I can just run it. And when I run it, I get this little UI. Very simple. It just has a couple of things on it. And if I'm using the guess engine, I can start the engine. And at the bottom, this kind of ongoing ticker will tell me what is my what is the fuel that I used, the amount of fuel. So then I can stop it, and it goes to start it again, restart it, and I'll just keep going, right, monotonically increasing. So that's my gas engine. And then my second kind of engine is the electrical engine. And so for the electrical engine, well, actually it doesn't use any fuel, so that's easy. So you could start the electrical engine, you could stop it, doesn't really matter. It's not going to use any fuel, at least combustible fuel. So this is a very simple example. And if you look at the engine UI, so it has 4 files, right? So you have the engine interface, and then you have the 2 kinds of engines. You have the electrical engine, and you have the gas engine. And the engine UI is the class that sort of creates the screen, right? It's going to create these radio buttons, it's going to create those buttons that I press, start and stop, and it's going to interface with the engines that I have. And it's kind of long, and there's a lot of crafty UI coding here. But the key thing for you to take away from this example is that inside the engine UI class, I'm defining an engine instance of type capital E engine. Right, so the UI class doesn't know that there are these different kinds of engines, right, that implement this interface. It just thinks of them abstractly as, as an engine. So the interface provides us a common type for describing a broad set of engines. So if you look within the engine interface, what does my interface contain? It doesn't implement anything, right? It just contains signatures of the methods that every engine should implement. And so here, you can start an engine. And so we have the spec for all of them. So you can start the engine, doesn't require anything, modifies this, effect the engine is running. You can stop the engine, right, which corresponds to the other button. And then you could check how much fuel did you use. Right, and so fuel used, it takes a distance, it takes your speed, returns a string that you can then use to populate that little box when you run the application. Yeah.
So is it like all engines start and stop and use fuel? And but the way they do it specifically, it depends on the type.
Right. So all engines have these methods because all engines have some way of starting, have some way of stopping, and all of them use energy. right? So this is defining kind of an abstract type of engine. And then the details of exactly how much energy does it use, how exactly do you start it, do you stop it, that's left up to the implementation. So as you would expect, if you look inside the gas engine, right, it implements engine. And so it contains those same methods. It contains the start method, it contains the stop method. So a gas engine, it tracks a little boolean to track whether the engine is on or not. So when you start the engine, you set it to true. When you stop it, you set it to false. And initially it's false. And then also has a little integer to track the amount of fuel that you used. So that of course comes in when you want to compute your fuel used. So down here it checks, okay, am I running? If I'm running, then I will compute the value of the amount of fuel used based on distance and speed. Like right now it just multiplies distance by speed and then just adds it to the current value. So very simple. And then on the electrical engine side, it's even simpler, right? I only maintain whether I'm running or not. So yeah, I could start again, I could stop. And then fuel used, well, it returns a string that says, who cares? I'm electrical, right? So those are two implementations of engine. They're very different. They represent very different kind of concrete instances of engine, but they have the same common characteristics, right? And that's what you use to define an interface. That's what you factor out into an interface. So another way to actually show this is using the class diagrams that we went over before. Remember the class diagrams? The UML class diagrams? Those are the really, really boring ones, right? Yeah.
So we would use an interface to define a data type if we could think of several different implementations of it, basically.
Yeah, generally that's what you want to do.
We want to use an interface.
That's right. Well, it's also when you want your code to depend on kind of an abstract version of those implementations. Right? So like this UI class depends on an abstract notion of an engine without caring about the specifics. Yeah, so the class diagram. So this should be a review for you. In terms of models, these were the really boring models, right? So basically, we had, if you look at this code, there's the gas engine and there's the electrical engine, and so you can create two boxes and say, okay, so there's gas engine, and the gas engine has some fields and it has some methods. And then I could do the same thing for my electric engine. And some fields and some methods. Now, in the UML class diagram, you can actually represent interfaces as well, not just classes. So what you would do is draw another box. And this box would be for the engine interface. And the way you know that it's an interface and not a class is that you're going to use cursive palette to write the name of the engine. I know it's bad if you're writing on a paper. So this is an interface. Guys, they're both classes. Okay. Now, before we just basically drew these little boxes and we stopped there, right? So the engine has some fields, and then the methods that it has are start, stop, fuel use, right? Okay, so previously we would stop here, except that now there's actually a relationship between the classes and the interface. Because the classes, each of these classes implements the engine interface. So the way you would denote that in a UML class diagram is that you create a little arrow to this guy. The arrow would be that. So this relationship is the implements relationship. So this thing tells you that the electrical engine implements engine, and gas engine also implements engine. So in effect, what it says is that the methods that you have here, right, they'll also appear within each of these boxes. Because they have to be, right? This is what it means to implement an interface. Okay, so what I've done is just visually describe to you as a model our relationship between the engine interface and the gas engine and the electrical engine. Any questions? Okay, so what we'll do now is actually create a new kind of engine. Right, so when we create a new kind of engine, what do you think I have to do to this model? What is that going to look like?
To add a new box, a new class.
I have to add a new class. So let's call it the diesel engine. And then what? Is that it? So my diesel engine is going to implement the interface, right? So I'll have the same relationship to the engine interface, the implements relationship. Right, so this is a to-do. I want to do this, right? So now we'll actually carry this out. So that's what we want to do. Now we're going to do this in code. Right, so in code, adding a new class means I have to add a new class to the project. So this is getting really concrete now. Right, how do I add a new class? I right-click on the package, and I say new, and class. So this creates a new class, or it gives me a dialog for creating a new class. And so this thing is going to be the diesel engine. So here's my diesel engine. And it's going to implement an interface. So I'll add an interface. Here it's found engine automatically, but you could just type it in. So I wanted to implement this engine. Okay, and I'll create it. So here I have public class diesel engine, implements engine, exactly as we want it to, except the implementation is empty. Right? So each of these is a to-do item. I have to fill them in. So if we want it to be implemented, we have to actually fill in the implementation for these. So let me just kind of start doing that. So I'll have a private variable boolean that will track whether my engine is running or not. Right? So maybe engine running. For this boolean, I probably have to instantiate it or initialize it somewhere. So I'll need a public diesel engine constructor. Where I'll say engine running out equals false. Initially it's off. Then when I start my engine, what happens? How do I update my internal state?
Engine running equals true.
Engine running equals true, right? It started the engine. When I stop it, this set it to false. It's no longer running. And now we have this complicated function to fill in, fuel used. So what are we going to return here? Kind of return whatever we want. I'll return a new string, and maybe I'll do some computation first. So I'll say integer d times s. Something like this. Right, so if I'm giving a distance and a speed, I'll compute the product, and then I'll return a string that'll say used up plus whatever this thing is. Of course, I could have done, there are multiple ways of writing this down, so I could have just said return some string f used, and then I could define a string f used up here to be the string. Right, cool. Just bundled a couple of things. Great, so we have an engine. We have a new kind of engine, diesel engine. So what I've done is just created that class. So this is just a class diagram. It doesn't tell you anything about how the application actually uses that class. Right, so in my application, this engine UI actually has to know about these different engines because it has to create them. So inside this long, ugly Java code, you'll find that there's going to be statements like engine equals new gas engine. This is where we actually create an instance of the gas engine. So this is what happens when you click on one of those radio buttons. Here's what happens when you create the electric engine. So I added a little bit of code that I'll comment out now, which creates the diesel engine, which we just added. Probably have to import it. Okay, so if we run it now, here's what happens. We have three kinds of engine, right? I have my gas engine, I have my electrical engine, and then I have my diesel engine. You can stop it. Stopping doesn't do anything. Probably a bug. I can start it, starting doesn't do anything. But I think if I go back to it, oh yeah, I remember it's a little borked, right? It's borked because when I stop it, actually, the diesel engine, this fuel use thing, it doesn't check whether the engine is running or not. Right, so I actually need a little variable to check. So right now, this engine running variable, I'm not using it in any way. I'm just setting it. But of course, if I want to check whether fuel, how much fuel I'm using, I would check if engine running. Then I would do all of these things. Right? And maybe otherwise I return new string, not running. A little bit more complicated now. So I'm now checking if the engine's running. I'm computing how much fuel I'm using, returning that. And if it's not running, I'll just say, hey, it's not running. So put this one and start it up again. See what happens. So I'll start my gas engine, my electrical engine, my diesel engine, not running. I start it, stuff will happen. If I stop it, it'll say not running. Right? So the big benefit of interfaces in this example is that this UI window essentially doesn't know about the kinds of engines that exist. It just calls those internal methods on every engine, regardless of what concrete type it has. Okay? So this is another example where interfaces are sort of helpful. Questions? Anything confusing? Interfaces? Yeah. How do I put the diesel engine in the what? In the UI. Yeah, so if you look inside the engine UI, there's actually a bit of code that I pre-wrote before the lecture that actually created these things, right? So it created a radio button, it created an engine button, and so forth. So this little bit of code is the one that's responsible in the UI for generating those little controls. But that's it, right? So once I created this diesel engine, it knows that it's an engine, and it just uses it as a very abstract form of engine. So don't worry about the UI code. You're not going to have to write UI. Definitely don't want to write Java. Okay. So that's basically the lecture today. What we'll do with the rest of the class is actually go over a lecture lab. So as before, the idea here is that we're going to practice some of the concepts that we learned. It's going to be essentially practicing data abstraction. So you can download this, this little doc from the schedule for today, the data abstraction lecture lab. And it's just going to be this guy. And so now on your own, just go ahead and start solving one after the other, one problem after the other. I'll go around to help you guys. And then I can also write code here once we have a solution. Okay. It's a demo for you how to do it. So for this lab, you're going to have to check out integer set lec lab. It's essentially the same thing as integer set complete. It contains the same classes that we went over in the last lecture, except that now you're going to be modifying it. So just open up, import a new project that you can start to modify, add specifications, and so forth. And raise your hand if you want to come over, and I can answer any question. Well, when you have an interface, you're not inheriting from there is a difference. There's a big difference. But we're going to go over it once we don't jump in.
It's like
They're very similar, and you would use them in different circumstances. Okay, so let's do the first one together. So I have the integers interface. Right, so the first question is, add a specification for the following method of the interface, the method intersection. returns a new set that is the intersection of this set and another set. So what that means is I have to add a new method at the very bottom, maybe at the top, doesn't really matter. Just add it at the top. So what should I write? We could start with either the specification or the signature of the method. Who can give me the signature? Come on, guys. No one completed it yet? Yeah.
Public integer set,
Public integer set,
yeah, and then intersection.
intersection.
I'm not sure what they just like that. Integer set A, comma, integer set B.
Integer set A, comma, integer
Set
set B.
And then set.
Right.
I'm
So,
not actually sure.
what do you guys think about this? Does anyone have a different answer?
Just have to do
In the bracket, integer set a new set.
So in the bracket,
Or integer set the type and then new set.
say that again. Integer set what?
And then new set.
New set. And that's it? Anyone else? Other solutions?
the question.
Yeah.
Does it have to be a specific type, like a hash set or a linked list for it to work? I don't, because integer set is just interface, so I don't know if you're able to.
Right. So this is just defining the generic method of intersection on an integer set that could be anything. Right.
I don't know, so.
Right. That's the intent. This is why we're changing the interface, because we want all possible integer sets. Right? So we're changing kind of the underlying type. So which one should I use? What's the right answer? What do you guys think?
The second one, because you're kind of on the intersection tree and you said that you put in a correct integer set.
Yeah, so the key thing to keep in mind, so this is the one you want, the second one, not the first one. Right? So this is wouldn't say wrong. You could still do it this way. It's not the best way of doing it. The reason you want this is because when you call intersection, you're already calling intersection on an integer set. Remember this keyword? So this keyword is going to be available to you within the intersection method. And so you need just one other set, the new set. You could call this whatever you want, right? Typically you call this other. You could say other set. Or A or B, it doesn't matter. It's just a variable, it could be renamed. Okay, so what would be the, what would be my specification for it? So I need three things, right? I need modifies, I need effects, probably before all of this, I need requires. So what should be my requires? When can I call this method?
One integer set.
When you have an integer set. Well, you know, when you have an integer set, you just pass it in and you call it. If you don't have one, you can't call it, right? So the answer here is that it's going to be true. You can call this method whenever. There's no constraint. Remember, there are constraints, for example, in remove. So when I'm attempting to remove something, I have to require that the thing I'm removing is part of the set. But to take an intersection of two sets, doesn't matter. If you have two sets, you can always intersect. Right? What about modify? Will it modify anything? See the signature? It returns an integer set. That's going to be my intersection. So it's not going to modify anything. Very simple. And then the effect is basically stated within the problem definition. Right? The effect is that the dissection of the sets contains common elements. So this will basically say, returns a set that contains the common elements between this and the other set. Great. That's the answer for the first one. All right, keep working on those ones. Yeah, so this thing is on the schedule. You can go and download it.
Oh, it's because it doesn't have everything left. That's why. That's because you have to use it. Right.
Requirement that the word add is satisfied by the requirement. In order for you to call into section,
Right,
you have
but
to pass
it's
in an instance of it. Sometimes people specify things in the requirements, but same, at least within the context of our class, we're not going to specify the parameters that you call in the requirements. So you could, if you really wanted to be down, if you wanted to be extra detailed, but generally
Oh no, linked to list.
other classes or other objects, you want to
Try that.
what is modified with higher. So when you're modifying something externally, what is it?
And every time once it's also return, just return Returnal method, because like now as a public integer set and there's like integer set public set, that's that the thing has return integer set. So you could just have it return like the other set. That's why it returns on the set. So no, return
It's curly braces. After the semicolon,
Did you just say that? What is it?
after the brackets.
you get
Not seeing the fields for
Oh, yeah, that's right.
exactly. So this is broader than specific. So which fields are modified? But sometimes when you're writing modifies for another function,
Actually, that solution. Seems like you never use that for you haven't
maybe we can do this.
creating a group
Yeah, so it's you'd have to have a new one for every different.
Yes, for every intersection. Even for the same
New set and the current set. Yeah, so we probably.
Yeah, I know, but
So
you wanted to modify it?
I thought
So that depends on the So that specification says that it returns
Yeah,
an
but-
integer set.
No, that's all
And it
you have
returns
to
a
generate by the clips.
So if that specification is good, right, if it said
But I
that
don't know if
when you
that's
interstate like A and B, you retain things that or remove things. Then you would change them. You would have a different.
Is your construction?
So it depends on your
but why?
Oh, the first one is wrong because you're passing. Well, because this is already an integer set. So you're doing an intersection of this. You could use the one of but the second B is extraneous.
This
Right?
thing has to return.
Yeah. I haven't.
Oh, we're gonna write that. Actually, it's one of the exercises down there. Okay, let's do the other questions. So we added the specification. So the second question is, what happens? What do I notice about my project? Okay, so my project now has these red X's. And red X's are compilation errors. Okay, so if I click on any one of them, basically it has a little X in the gutter, and that tells me what the problem is. And I have the X's in each of the implementations of integer set. Right? And the reason for both errors is that they're not implementing this new method, the intersection method. Right? That's the problem. So I added a new method to the interface. So now I have to update all the classes that implement that interface to implement the new method. Okay? So that's really so that's the answer to this guy. So the way you would get rid of these errors is really what question 3 is getting at. So in this class, like let's say the linked list integer set, it has an error, right? It does not implement the interface right now completely because it's missing a method. So I need to add a method at the bottom. And that method is going to be the intersection method that we just added to the interface. So it's going to be public integer set intersection. So this is, what's the problem? The problem is that I need a return statement. So question 3 is getting at the fact that you should add a stub in order to make your project compile. So a stub is an empty implementation. And the reason we're adding a stub is because we want the project to compile. Perhaps we want to run the test, but we can't because it's not compiling right now. So to make it compilable, I have to resolve all the compilation errors. So here I just have to return something. So what I'll do is I'll return null. So by returning null, I'm returning nothing, essentially. And that makes the compiler happy, even though this is not the correct implementation of intersection. So this is an example of a stub. Okay, so I added a stub to a linked list, and notice that it's now no longer red. So I need to add the same kind of stuff to the hash map integer set. Exactly the same stuff will work. Okay, so now my project compiles. Yeah.
When I clicked on the error message, which is on the left side of the public class, it recommended me importing the method, and when I clicked it, I got the same method with the at override on it. What is the difference?
Yeah, so at override that you mentioned is an annotation. For interfaces, it doesn't really matter, right? You could have it or you could not have it. We'll cover actually in more detail on Friday what override means and why you use it for another case. Any questions about the solution? So I added 2 stubs, made my code compile. So that's solution for 3. So now this is getting at the actual use of my data abstraction. Right, so this was a stub for our implementation, this was specification, and this is getting at how are you going to use your data abstraction. Now that you've added this new method, the intersection method, how do you actually use it in code? Okay, so here you need to just fill in this line of code at the very bottom to intersect set A and set B.
Is there a built-in method to do that, or do you have to iterate through the list?
Well, you're talking about implementation, right? So this is getting at the use of that method. So to implement it, yeah, you could use some internal methods. But this question is really just getting at how do you invoke that method? How do you call it? So anyone want to give me a solution to this one?
Intersect A, B equals set A dot intersection bracket set B.
So this is one solution. Right, I'm just saying set A, this instance of integer set that I created here, and I'm calling intersection on it, so this is a dot, and I'm passing in the set B. And so the output of this, the result of this operation, will be assigned to set intersection AB. What's another way of taking the intersection?
Set B intersection set A.
That's right. So there's another way of doing this, and they're equivalent according to the specification. I could do set B dot intersection, and then let's give set A. Those are the same, according to the specification. So this is how I would use my new feature in my data abstraction. So there's 2 more questions here. You can answer this on your own. And you could post to Piazza and ask questions about how to do them, and then we'll give you answers for those as well.